Okay, so today's topic is the inverse of a square matrix. So a square matrix has the same amount of rows as it does columns. So a 2 by 2 or a 3 by 3 or an n by n is considered to be a square matrix. We use the phrase order of n, order of size n. So order of 2 means that it's a square matrix that's 2 rows by 2 columns, and order of 3 means that it's a square matrix that has 3 rows and 3 columns. Another vocab word to know is the multiplicative identity, which is this particular square matrix. If you notice, it has one diagonal where all of the elements are 1. This one also has one diagonal. It's the main diagonal from the upper left down to the lower right. And all the other elements are equal to 0. So these are called the identity matrix. And a notation for that would be I with a 2, and this would be an I with a 3. So I stands for identity, and the 2 stands for the size. So 2 by 2, and the 3 is the 3 by 3. When we're talking about matrix multiplication, if we take two matrices, A and B, and multiply them in either order, so A times B or B times A, if they multiply to give you the identity matrix, then that means that A and B are inverses of one another. So A is invertible and B is the inverse. If it's not possible, then that means that maybe the original matrix A is not invertible, and it would be called singular if it doesn't have an inverse. Every square matrix has at most one inverse matrix. Inverse of matrix A is called A with a -1. This is the symbol for inverse. You don't say A to the -1, you just say the inverse of matrix A. So example 1 says find B times I and I times B. So I is the identity matrix. Example 1, we're going to find B times I and I times B. Since matrix B is a 2 by 2 matrix, when we multiply it by the identity matrix, which is what I stands for, we have to multiply it by another matrix of the same size, because in order for two matrices to be multiplied, the number of columns in the first one has to match the number of rows in the second one, and all identity matrices are squared, so it has to be a 2 by 2. And so we're just going to write down what the identity matrix is. It's going to have 1s in the main diagonal from the upper left down to the lower right, and then it'll have 0s for all the other elements. All right, so we're going to multiply this by hand. And as a reminder, when we multiply this by hand, you're going to multiply one whole row by one whole column, and you're going to distribute each element, so the first element in each, so 1/2 times 1. And then we're going to add that to 5 times 0. And then we're going to keep distributing that row to now the second column. So we're going to do 1/2 times 0 plus 5 times 1. And then we're going to go on to the next row, and we're going to do the row with the 3 and the 1 times the 1 and the 0. So 3 times 1 plus 1 times 0. And then we're going to finally distribute the 3, 1 row to the column with 0, 1. So 3 times 0 plus 1 times 1. All right, when we multiply and add, we get 1/2 plus 0, that's 1/2. We get 0 plus 5, that's 5. We get 3 plus 0, that's 3. And we get 0 plus 1, that's 1. So if you notice, the beginning original matrix B ends up being the answer as well. 1/2, 5, 3, and 1. And this was multiplying B times I. All right, now we're going to go the other direction, I times B. So that means we're going to take the identity matrix, which is the 1, 0, 0, 1. It has to be a 2 by 2 in order to multiply with the original matrix B. So 1/2, 5, 3, and 1. And we're going to multiply the same thing. So we're going to take the top row and the first column. And that's going to give us 1 times a half plus 0 times 3. And then we're going to keep distributing that top row to the second column now. So it'll be 1 times 5 plus 0 times 1. And then we're going to move on to the second row. So 0 times 1/2 plus 1 times 3. And then we're going to continue to distribute the second row 0, 1 to the 5, 1. So that's 0 times 5 plus 1 times 1. All right, so if we simplify that, we're going to get 1/2 plus 0, that's 1/2. And 5 plus 0, that's 5. And then 0 plus 3, which is 3. And 0 plus 1, which is 1. All right, so if you notice, this is matrix B yet again. So what we're supposed to figure out is that if we do I times B and B times I, we get matrix B no matter what order we multiply it in. So any matrix times the identity matrix should give you the original matrix. All right, so for this next section, we're going to use our graphing calculators to calculate the inverse matrix. So first thing we're going to do is we're going to input this original matrix into matrix A. You can put in any matrix name that you want, but I'm just going to choose that one because that's the first one. So I'm going to hit second matrix. I'm going to move over to edit. And then remember, anytime you edit a matrix, you have to give it the dimension. So this is a 2 by 2 matrix. So I'm going to hit 2, enter, and then 2, enter. And then I'm going to input the 4 elements. So I've got 0, -11, 1, and 6, and I hit enter after each one. All right, and then when you're done typing the matrix in, just double check that you've done it correctly. There's no mistakes or typos, any negative signs are there. Make sure you use a negative sign, not a minus sign. And then you're going to quit out of that. So remember, the symbol for inverse matrix is just a little -1. So we essentially just need to type that into our calculator. So we're going to quit, and we're on the main screen. You're going to do second matrix. And under the names column, you're going to choose matrix A. And then there's a x to the -1 key. So that gives us the -1 symbol, and that means inverse matrix. So if I hit enter, I get a decimal approximation. So notice that I'm going to write down a rounded version of this decimal. So 0.545, and then 1, and then I get -0.09, and then I get a 0. But I would like to convert that to a fraction. So if I hit the math button and change to a fraction, just like I would anything else, I get 6 over 11, 1, -1 over 11, and 0. And that's my inverse matrix. And that's it. All right, so we're going to do problem number 3. Same thing, except this is a 3 by 3 matrix. And I'm going to put this into matrix B just so I have matrix A in case I were to need it again. So I'm going to hit second matrix. I'm going to go to edit, choose number 2, which is B, and I have to input the dimension, so 3 by 3. And then I'm going to type in each row one at a time, so 1, 0, -2, and then -3, -1, and 6. And then the bottom row is 2, 1, and -5. And when I'm done, I'm going to make sure that I don't have any typos, because even one element or one positive or negative sign, if it's wrong, then the whole inverse matrix is going to be wrong. Okay, so now that I've checked that, I'm going to quit out of it, and I'm going to go to second matrix. I'm going to choose number 2 this time, which pulls up the name for matrix B. And then I'm going to find the -1 symbol, which is the symbol that represents find the inverse. And then I hit enter. This time I don't get any decimals, so I'm just going to write this one down. So I have -1, -2, -2, -3, -1, 0, -1, -1, -1. And that's my 3 by 3 inverse matrix. All right, problem number 4. try this one on your own and see what you get. And hopefully it matches with my answer. You can pause it and then restart it again when you're ready. All right, so when you're ready to get the inverse matrix, you're going to pull up the name of whatever matrix you put it in. And for me, that would be matrix C. So I'm going to find matrix C, and then I hit the -1 button to find the inverse. And that gives me 1, 4, -4, 2, 11, -13, -1, -5, and 6. And that's my inverse of the original 3x3 matrix. So this says solve the following equations given that, and they give us 5 different matrices. So they want us to solve for x in the matrix equation. So if it was just normal variables, we would divide by a on both sides to solve for x, but we can't do that because these are matrices. So instead of dividing, what you do is you multiply by the inverse. So if I were to take my original matrix equation, a times x equals b, and I purposefully left a space there, and I multiply by the inverse of the thing I'm trying to get rid of. I'm trying to get rid of a, so I multiply by the inverse of matrix A. These two things multiplied together, the inverse of matrix A and matrix A, that's going to give me the identity matrix, right? So we talked about this up here. As long as A and B are inverses, when you multiply them together in whatever order, it's going to give you the identity matrix. But then we noticed in example 1, if we took the identity matrix and multiplied it by anything, you get whatever that matrix is. So if I were to solve this equation and I do the inverse of matrix A times matrix A, that's going to give me the identity. And then when I do the identity times x, that's just going to give me x. Now, to keep my equation balanced, if I multiplied the left side by the inverse of matrix A, I would also have to multiply the right side by the inverse of matrix A. And so that's really what we're going to do here. So get x by itself. So we know that I need to do the inverse of matrix A times B, and they've conveniently already given us the inverse, so we don't have to come up with that on our own. This would be on a non-calculator part of your quiz. So this is -9, 7, -4, and 3. And I want to multiply that by matrix B, which is 30, 39. Okay, so now remember, when you're going to multiply, you're going to distribute the top row times the column. So you're going to do your best to do this without a calculator. So we have -9 times 30 plus 7 times 39. All right, so if I do -9 times 30, I'm going to get -270. And 39 times 7 is going to give me +273. And then if I distribute the second row times the 30 and 39, that's going to give me -4 times 30, which is -120, plus 3 times 39, which is 117. And that's going to give me an answer of +3 and -3. So that's my answer in matrix form. Okay, we have 2 more questions like this. So we know that what we need to multiply by is the inverse of matrix A. And if you do that on the left side, you have to multiply that on the right side. So the inverse of matrix A and A are going to cancel out. You don't have to write down that gives you the identity matrix, but that's why it cancels out. And then multiplied by x is just x. So we just need to look at what is the inverse of matrix A, which is this -9, 7, -4, and 3. And we need to multiply it by -45 and -71. All right, so we need to do -9 times -45 plus 7 times -71. And then in my bottom row, I'm going to have -4 times -45 plus 3 times -71. All right, so we're going to do our best not to use our calculators. So if you need to do some math off to the side, we're going to do 45 times 9 That gives me positive 405. And then 71 times 7 gives me negative 497. Subtract 405 minus 497, I get negative 92. 45 times 4 would give me 180 positive. And if I do 71 times 3, that gives me negative 213. All right, so 180 minus 213 is negative 33. And, sorry, these should not be fractions. So I just have a 2 by 1 matrix, and that's my answer. So for this problem, we just need to find the matrix D inverse, which is this 1, 2, negative 2, negative 1, 3, 0, 0, negative 2, and 1. And I need to multiply this by matrix E, which is 28, 9, and 22. So I'm going to take the first row, multiply it by the only column in my matrix, and I get 1 times 28 plus 2 times 9 minus 2 times 22, which should give me 28 plus 18 minus 44. And then for row 2, I need to take the negative 1, 3, and 0 and multiply it by the 28, 9, and 22. So that gives me negative 1 times 28 plus 3 times 9 plus 0 times 22. So that's going to give me negative 28 plus 27 plus 0. And then the final row, I need to multiply the 0, negative 2, and 1 by the 28, 9, and 22. So that would be 0 times 28 plus negative 2 times 9 plus 1 times 22. So when I add those together, I get 0 minus 18 plus 22. All right, so the last thing we need to do is just add across in our rows. So 28 plus 18 is 46, and 46 minus 44 is 2. And then negative 28 plus 27 is negative 1. And then negative 18 plus 22 is 4. So your final answer should be 2, negative 1, and 4.